Hey everybody, welcome to our continuing odyssey on the world of shapes. Yesterday we looked at the Pythagorean theorem, and you are going to need yesterday's knowledge in order to do today's work. So if you think you know the Pythagorean theorem, start working through today's stuff and discover you're having troubles. There is another lesson that you skipped that you probably shouldn't have. Go do it. This also is a review lesson. You guys would have started doing this, or at least you should have started doing this back in grade 8. So I'm going to whisk through it, hoping that you have. Worst comes to worst, if you don't understand what I'm talking about, you're welcome to rewind, listen to it again. If you're lonely and you just miss math class, you're welcome to rewind and listen to it again. Um, yeah. Okay, so a composite figure is made up of more than one simple shape. So there's lots of things in real life that just aren't one of the basic shapes that we know, but we could break it down into smaller pieces that do look like circles, squares, triangles. You know, one of the basic shapes that we do know how to find area, perimeter, and when we get there, volume. So determine the area of a composite figure by adding or subtracting the individual pieces. And likewise, to find the perimeter of a composite figure, add the lengths around the outside of the figure. Now, I'd like to say that it's perfectly obvious and everybody knows you don't use the inside lengths when you're doing the perimeter, but I always find people do. So be aware, only the outside. Now, don't worry. If you haven't already, there is a formula sheet that you would have gotten for EQAO, which, glory be, you don't have to do this year, assuming, of course, you're watching this in 2020. But it is available in case you don't have all these formulas memorized. I think I go through it a little bit in this one. I guess not. But if you don't have these formulas, you can Google them, or there is a formula sheet I will have at the beginning of the section that you can use. So area of a triangle, straight off this formula sheet. I have all this stuff memorized because I'm a big fat loser. If you have it memorized, you're cool, but not me. Okay, and remember, units are squared for area. Area of the rectangles are length times width. That's why I didn't do that. 3 times 4. Area is 12, so the total area, notice I'm using that subscript T, 8 plus 12, for a total of 20 meters squared. Okay, so I added the triangle, I added the square. The perimeter, it only includes an unknown side length. So we don't know what this part here is, right? We know this, we know this, we know this. This is a question mark. So we got to use the Pythagorean theorem in order to figure that out. So what is that? 4 squared plus 4 squared equals c squared. Now, how did I know? Well, because if this section here is 3, then 7 minus 4. Come here, erasinator. There we go. So if 4 minus 3, so it's actually a square. So that makes our perimeter 7 plus 4 plus 3 plus 5.6569. What is that? 19.7. So notice again, I'm using my 4 decimal places all the way through. And it's not until the last step that I'm rounding them. So, well, yeah. So that was supposed to be on the outside. That was supposed to be below that. Now, this is a favorite of EQAO. They love these circle things. And I want you to notice, no, there we go. They're going around the outside. Two halves. It's like leaves. Two halves equals one whole. Okay? So, when we're trying to find the area and the perimeter, if we can treat this as though it's a whole circle. Now, in case you've forgotten, these little tick marks mean everything is the same. Okay, so what are we going to do first? Oh, let's do area of the circle. Now, a lot of my calculations, I use the pi button, and there is a difference between using the pi button and the 3.14. In fact, it's the same difference that I'm telling you about the 4 decimal places. The more decimal places you have, the more accurate it's going to be. If you use your pi button, that is exactly pi. It is not an approximation of it. So if we were to use pi, so this one's 3.14, and there's the answer. With the pi button, oh, tabernacle. There is a small but important difference, 24 versus 26.5. And these little differences add up over time. You'll also notice that I'm using little subscripts. Now I'm using lazy subscripts. I'm using circle and square. Uh-oh. Okay, my computer's glitching a little bit. Hopefully I can get through the lesson before my computer goes kablooey. Technology is wonderful. Okay. Now, for some reason in a circle, we call perimeter circumference. And I don't know why. We just do. All right. Any mathematical relationship is fine. I'm going to be a little lazy, and I'm just going to find the area of this one because I'm pretty sure you could do the perimeter on your own. But we could extend this, in which case it becomes the area of the large one, 18 times, what? Cool. Oh, I started writing the 10. Neat. And then the area of the triangle, I guess that's really just area of the square. How did I get those numbers? Ah, glitchy, glitchy. Come on, baby. Hold on. Just hold on. 5 times 8 is 40. Cut in half is 20. So therefore, area total equals 126 minus, because it was cut away, and that's the story of a girl. Cried a river and drowned the whole world. Okay, so this is the last of the review. As of tomorrow, we start hitting new stuff, and your life gets to be a little bit more difficult. Good luck, guys. As always, give me a shout if you're having troubles.